Thank you very much, Chair, for giving me this opportunity to talk about. So I'm going to touch base on a different angle of these presentations, of the previous presentations that I've gone through. I'm touching base on the actual science, on the research that have been done. I've done most of this research before I joined the ARC. So I will explain a little bit of where I was and what kind of training did I obtain and what do I specialize on. So the topic of today, what I'm going to talk about is a combination of future chill units and water scarcity on South African deciduous fruit production industry. So my main focus is it developed when I was still doing my master's level. When I was doing my master's, I focused more on chill units and climate change, and then which is what contributes towards the fruit quality in the fruit industry. And then I'm like, this is not only the case, then what about water? So because it's a combination, but you will hear and you will create a link when I go further with my presentation. So first thing that I do, I'm an agrometeorologist. So most of the people they get to ask me, what is agrometeorology? What do you guys do? It's just a simple study of using weather and climate information just to enhance crops and increase crop productions and just to focus on the impacts of weather on agriculture or in combination of agriculture. It's called agricultural meteorology in simple terms. And why did I study this agrometeorology and how was my journey in this agrometeorology sector? So I started my professional career as an agrometeorologist at Amalgamated Banks of Southern Africa, which is ABSA. And most of the people ask me, what were you doing in the bank? As an agrometeorologist, I was working in the AIC section, which is the Agricultural Crop Insurance Division, wherein we deal with what you call multi-peril crop insurance and also the hail section, hail insurance. And then I moved to South African Weather Service, wherein I worked as a senior scientist at the Climate Information Service section. And then I worked at CSIR as a research technologist. That's where I learned more of the technologies that I've been using currently in my research. And then I joined the University of the Free State, that is in 2015, as an agrometeorology lecturer. And in that sense, I managed to produce quite a number of graduates, and some of them are working with me here at ARC. Some of them are working at different companies, the departments. So for the past 8 years, I've been at the university. I've managed to produce quite a number of graduates in postgraduate and also in undergraduate. So now I've joined the ARC since last year, August, as a researcher in agrometeorology. So during my journey, because in order to be a recognized scientist or in order to do research that will add value, you need to have some sort of training. So in my case, the training that I've obtained, I usually say if you manufacture a sensor or if you manufacture an equipment, it is better for you to train me so that I can learn it from the horse's mouth, from those who created or who manufactured the instrument. So I received some of the training of Eddy Covariance systems that I use from Campbel Scientific in Logan, Utah, where they manufacture it. I also had a collaboration with UC Davis. They trained me on what we call low-cost systems that we use for determining the evapotranspiration or water use. And I also went with Kipp And Zonnen in Netherlands, where they're training me on how to use the Scintillometer systems. And I also, someone in the presentation was talking about Neon Data Center. They trained me on their flux systems. There in Boulder, Colorado, I had to go there for a period of 3 weeks to be trained on how their systems works. And I had collaboration with some of the renowned scientists like Rick Snyder in the field of agrometeorology, and also collaborating with a team from UC Davis in California, working on the projects together. And also, these are some of the collaborating partners that I've been working with, international ones, is the Eastmoreland Research Institute in Naib, which is based in UK in Canterbury, the NOAA, which is the meteorological organization in the United States, and also with Reading University at the Brockdale Research Site, wherein we are looking at different fruit cultivars and how do they adapt to climate change. and then some of the collaborations, because I cannot just have collaborations with institutes in the other part of the world, but also in Africa. We are working with IAPRI in Zambia.
Dr. Tharaga,
Yes.
sorry for interrupting, but your slides aren't moving.
Oh, on my side, they are moving.
Yeah, if that's maybe minimize your presentation and look at the screen, the Zoom screen.
Okay. But can you see it now?
We can see your presentation.
Oh,
and you have moved the slides now.
okay. And that's surprising. Okay. Now, when I move, can you see it?
Yes.
Oh, okay.
Yes.
So
So now I see impacts of climate change on
impacts of,
accumulated
yeah,
chill.
this is the first topic that I will talk about. It's just few.
Okay.
I break down because my main topic is about the combination of different topics that I've worked on. So now
Okay.
here I'm looking at the impacts of climate change on accumulated chill units at selected fruit production sites in South Africa. So most of the people don't know about chill units. We are looking at fruit, more especially deciduous fruit trees are mainly exposed to cold temperature during the winter period. They go into dormancy. You might have seen even throughout those who are not in the fruit industry, you'll see, like if I can give you an example of what happens in Pretoria, the jacaranda trees, the moment during winter they are dry, they lose leaves, and then all of a sudden they start blooming and then they start developing leaves. This is what happens to the fruit trees. But for them, they need to accumulate to be exposed to certain number of chill units in order for them to give us to get the good flower, to get a good quantity of flowers, so that we can get a good quantity of fruits. So now the problem is, if they are now we are starting to experiencing the warming, what will happen now to this amount of chill units? Are the areas that are producing fruit trees going to accumulate the exact amount number of chill units which they used to have? So this is what has driven as the research that I've done when I was doing my master's. This is mainly part of my master's work. So we look at warmer temperatures reduce necessary chill, impacting fruit tree bud break and quality, and also while raising the evapotranspiration increases the irrigation demand. So the deciduous fruit trees such as apples, pears, and require specific number of cold winter hours or chill units to properly break dormancy and flower uniformly in spring. So if they don't reach this certain amount of exposure to cold temperatures, maybe more especially less than 7.2 degrees, they tend to we tend to now use the what you call the additional spraying system or spraying domex in order to account for the shortfall in terms of the number of chill units which were supposed to be accumulated by these fruit trees. And this has been happening due to climate change. So, and as South Africa warms faster than the global average, winter chill accumulation is decreasing, particularly in the vital Western Cape region. If you look at the Western Cape region, we have areas such as the Koubokeveld. In Ceres, we have the EGVV, which is Eligin, Grabouw, and Villiersdorp, which are all apples and pear producing regions. And you have the regions around the Klein Karoo, you have what you call the apricots production site, Berrydale, Montigny, and also you have Robertson. Even the wine zone or winery production sites, they also get affected by these chill units, because they also need a certain number of chill units in order for them to give us the good wine and the good grapes at the end of during the season. So we look at various growth stages. I've already explained this. Like during these growth stages, so during the dormancy period, you need to be exposed. Trees are needs to be exposed to a certain number of chill units, and then during the flowering, now that's when you start looking at the water demand also, and also during the all the growth stages, you need to look at the water demands. And but the main, so now the combination of your loss in chill units and then your loss in water supply, then they will have a huge impact on your fruit yield or on your fruit quality, and that will also have an impact on the amount of fruits that we'll export as a country, and that will also have an impact in our food security, because if we cannot produce the high number of fruits or the quantity of fruit that we will need for consumption and also for export, therefore that is a shortage that will have an impact on our food security. And then in South Africa, if you look at the fruit production sites, they are mainly aligned also with the climatic regions. So you find that there are certain fruits which are produced at certain regions. And if you look at the Western Cape, is mainly dominated by the deciduous fruit production, and you have the Eastern Free State, and then you have some parts of Mpumalanga, and then in Limpopo province, we have the tropical fruits also, and some part Northern Cape, where it's mainly table grapes, and also some few stone fruits. So, and that is also dependent on the chill units and also on the water availability. That's why at the beginning I'm talking about the combination of these two factors, your water availability, water scarcity or water availability, and chill units. So when I was doing this, I look at, okay, this was done during before the scenarios changes to the pathways and other things. So we're using the A2, the B2 scenarios, which still mainly the same because nothing is changing as people are continuously living the way they've been living for the past years. So people are not really changing their lifestyles to say they are saying climate change is coming. These are the consequences of climate change. We must change them. What I've seen and what I've observed throughout my life, people are not really changing. We are just actually we are even expanding. The population is just increasing and increasing and increasing. Majority of us also living in the places which are not supposed to live at, in floodplain zones and so forth. So, and then in order to get the good quality in terms of data and in terms of your if you want to create your predictions and say, okay, now what will happen in the future, you need to really have a clear understanding of what happened in the past and whether the models that you are using are really actually giving you the accurate data that you are going to use to create in the models in the future. Say, okay, our models are really giving us what they are supposed to give us. Are the outputs from the model really accurate? You need to look at it. We use the observed data, maybe 30 years of observed data, and you calculate it, and then you determine statistically, you compare it with what you have predicted and what you have observed, whether there is a good correlation. And if there's a good correlation, if there's a good fit in the model, then you can start using that data to create or to make informed decisions about it, and to say, okay, what I'm predicting, what will happen in the future, it might be accurate based on the fact that my model is able to produce what accurate data of what has happened in the past. So from there, I then look at what has been observed in terms of chill units in Southern Africa. So in these chill units, I focused on the three production sites, which is the Eastern Free State and the areas along the Orange River, Appington, Ograbis, and that whole area where they produce table grapes, and also Ceres, which is one of the main deciduous fruit producing sites. So I wanted to look at what will happen to the chill units in these areas, mainly in the future. So, and then I look at what happened in the past. And what happened in the past, if you look at this graph in Bethlehem, this is in Bethlehem in the Free State. So it started, there was a decline in the amount of chill units which they were accumulating due to temperature increases. And then all of a sudden you have another fluctuation, you have an increase, and then another decline. So it is fluctuating in a way that it becomes unpredictable what will really happen. Then I'm like, okay, let me go and see what will really happen in the future. So we did the probability of non-exceedance in terms of the number of chill units that we have been receiving. So the base one is what we have been receiving from 1981 to 2010, which is the black line here. And then we look at what will be the projection in the future from 2011 to 2040. So there will be an increase in Bethlehem in the amount of, so this is what we call a positive outcome in terms of climate change. So climate change here is affecting this area in a positive way, not in a negative way. So which means now the the area will now receive more chill units as compared to what was happening in the past. In this sense, we say, what are other fruits trees can we introduce in this area which are high chilling requiring fruit trees? Because this is an opportunity now. It is not really a negative impact, it's a positive impact what will be happening in the area of the around Eastern Free State. So even you, if you look at the time from 2071 to 2100, so this might be a boom in terms of, okay, this will be the area for producing most of our fruit trees, the deciduous fruit trees. Now, and let's look at what happened. You will see the dynamics, the change, the difference in regions. From one region to another, there's a huge difference. Now, moving to the next slide. If you look at what is happening in Ceres, this is what has been predicted for Ceres. In Ceres, they've been receiving a quite number of chill units, but due to climate change, the predictions of the models are showing us there will be a decline from 2041 to 2070. They will start experiencing a decline in the number of chill units which they accumulate. What does this mean now to those fruit trees that have been produced there? Or what will be the solution for this? Is the solution moving some of the orchards or starting to establish orchards in the areas of around Eastern Free State? Or we can send this message to the breeders and say, breeders, can you help us now by breeding or cultivars which are low chill requiring cultivars, of which some of the companies like ZZ2 has started doing this on sweet cherry productions. They are now producing cherries which are low chill requiring cherries, which they are producing even in Rustenburg. So which is also driven by such evidence of saying, okay, if now you start experiencing this, what will be the solutions? So the solutions are also forthcoming in terms of the industry also adapting to looking at this data and adapting to the new trends and say, what do we do now with when the scenarios are changing like this? So if you look at, there's a huge difference between Ceres and Eastern Free State. And if you look at 2071, it's a drastic shift. So this is your base of 1981, and then look at the shift. So you say you have a decline in the amount of chill units that will be accumulated in this area, and which is a huge decline. And therefore, now as a farmer in the long run, you need to say start deciding what kind of fruits will I start producing in this area. So this is driven by climate change, and therefore this information is already available for farmers. Some of them, or the breeders, needs to start thinking of saying, if this will be the situation in the Western Cape or mainly in Ceres, what do we do now? Now let's start implementing and testing most of the fruits that are low chill requiring fruit trees. And this is what is happening in Uppington, similar story to what is happening in Ceres. And then the only positive one was in Eastern Free State. So in this one, we say, what do industries do? The deciduous fruit industry is actively developing and implementing strategies to build resilience against these uh, interwind climate threats. So the cultivar selections that they are using, the industry is moving towards planning on low chill cultivars better suited for the warmer winter conditions. And water conservation, farmers are adopting technologies and techniques to maximize water efficiency using like drip irrigation, because now if you are going to have a combination of saying, if you are having low chill in the area and now you are experiencing water scarcity, what do you do? So we have a, you know, the industry leader or the industry representative in the fruit industry, which is Hotgrow. They are also funding some of the research into climate change impacts and adaptation. Farmers use low chill monitoring models to guide and manage decisions for specific orchards. So long-term planning with the new orchards having a long lifespan, projections for future climate conditions are now critical factor in investment decisions. And then the second part or the second leg is that now we understand now in terms of the impact of chill units. Now, what about water requirements? What will happen? So we need to look into. So this is my second topic of saying I'm now looking at, if I look at the sweet cherries and say, okay, the chill units requirements for sweet cherries is 1,000 chill units, and all of a sudden the area where I'm producing sweet cherries, they're now getting 800. Can I supplement this by using some form of irrigation to maintain my yields? So now I need to quantify the water use productivity of rain-fed sweet cherries or irrigated sweet cherry orchards in the Eastern Free State of Southern Africa using micrometeorological techniques, because I'm into micrometeorology. So this is trying to address the impacts of water scarcity in Southern Africa. South Africa is a water scarce country, and climate change is intensifying the water-related risk for the agricultural sector. And this is a major concern for mainly the deciduous fruit industry, which is heavily dependent on irrigation. So we have increased in water demand, rising temperatures drive this higher evaporation and crop water use, further straining the limited water supplies that we have. Drought-related losses. If you have seen what happened in the Western Cape uh, from 2017 or even from 2015 to 2018, the drought has led to significant drops in apples, pears, and apricots production and the exports of those products. So lower fruit quality also, when farmers must retain or ration water, they they may opt to save more profitable orchards at the expense of others. And this is what we have seen in Montague. When we started doing research on apricots, the main reason was it was driven because of most of farmers lost their trees and orchards trying to cut a cost because they didn't have water to irrigate. So they want to know what the optimum amount of water which each and every tree require so that they can irrigate efficiently and save more water and establish maybe more orchards or different orchards of different fruit trees. So this reduce also the profitability, because when you're farming for profit. You're not just farming to to sell and without making profit. You need to farm to break even and to make profit. So as seen with droughts, the financial impacts on farms can be severe, including cost of water saving technologies and removal of older orchards and losses from smaller and damaged fruits. Because if your fruits are not big enough, you cannot export. And then if you sell them in the local market, you end up not getting value for your money. So there are different techniques which have been used to quantify this. So I'm not going to dwell much into these techniques because it's micrometeorological techniques. I'm just going to show. So there are several studies which have been also conducted on water for water use analysis in orchards, in vineyards, and also in forests using micrometeorological techniques between 2013 and 2019. In this is globally. You'll find the studies which are done in Chile, in other parts of the world. And then let me go to what has been done in South Africa. There are studies which are done in vines by Maybeck, apples by Dr. Zikiti, and also citrus by Dr. Nikki Taylor, on pecan, Ibrahim Onaidia on pecan and macadamia, apples by Dr. Nchiri, Gash and Taylor. They did a lot of studies on fruit trees. These were mainly funded by the Water Research Commission, the water use in agriculture. So we use different techniques such as set flow, eddy covariance system, and soil water balance just to understand what is really happening with the soil, plant, and atmosphere continuum, because you need to understand what is happening in the plant, what is happening in your soil, and what is happening above the crop canopy, so that you can make an informed decision of saying what are the water requirements, what is the amount of water which this tree requires on a specific season or on a specific growth stage, so that you can make an informed decision, or you can give a farmer an idea of saying, this is how much you must irrigate when your trees are starting to flower. This is how much you must irrigate when your fruits are developing. This is what you must irrigate when your fruits are ripening. This is how much you must irrigate during the post harvest, when you have already removed all the fruits, when you are accumulating carbohydrates for the next season. So to make such informed decision, you need actual research being done in the farm. And also, after this, when we are done with this, we can develop apps which now farmers can just do what you call plug and play and make decisions on water requirements. So these are some of the results that came from different studies to show that during flowering you have limited little amount of water requirements, like 3 liters per day, and then rising to during fruit development to 6 liters per day to 8 liters per day to sometimes 12 liters per day during your post harvest when the trees are at full canopy. And then all this is also driven by your weather. So your amount of rainfall during the season, and also the temperature effects on this. So now when the temperatures are increasing, what will happen to your transpiration rate? That's why most of the time, if you are driving around farms and you see now, oh, these trees are having yellow leaves, and this is like during the middle of the season, you start asking yourself what is happening. Mainly it's water stress, which means now they are not getting enough water, and the temperatures are so high that they cannot even maintain themselves, because most of the trees, when they reach certain thresholds, they start closing their stomata. They try to regulate themselves. I will show you by a graph now. If you look at this graph, this is sweet cherry trees. The moment they reach a certain temperature threshold, then during the day, like during the time of the day, they close the stomata so that they try to regulate the amount of water loss from them. They're trying to make sure that they have enough reserves to survive those temperatures. And this happened during from one season to another. Okay, now the second part, because we cannot focus mainly, we are focusing on fruit trees. So the first part was the sweet cherries. Now we have also conducted a study on pomegranates orchards, and we just recently came back from a pomegranate conference in Italy last week, wherein one of my students won an international award on the best presenter. And then these are the systems that we are using. Same systems that we used in sweet cherries are the same systems that we are using in pomegranates to understand the water requirements. And also there is an expansion in the pomegranate orchard production in South Africa, and we are competing with countries like Peru, so that we can also, and Chile and Argentina, because we're in the southern hemisphere, more especially in terms of delivering to the market in the Western countries. So we use different systems like the Eddy Covariance systems and also the remote sensing techniques. And to understand all these qualities, there are different techniques that we are using, because each and every quality that we produce, it needs to go for an export. So, and we also need to look at how much water is required to produce a certain quality of the fruit, a certain fruits that of the certain color, and which cultivars require certain amount of water. If the cultivar requires so much water, is it worth you producing it, or we need, so that we can give guidance to the farmers and say, if you really want to be profitable, this is the cultivar to go with in terms of water requirements, and also in terms of the chill units requirements, because of the suitability of the microclimate within your area. And this is some of the results which we have got from our just analyzing because the study of pomegranates, we're conducting it in Avontir and also in Wellington in the Western Cape. That's where there is highest production of pomegranates in Southern Africa. And if you look at the seasons, that when you talk about weather and climate, if you look at what is happening during the 2022 seasons, just this graph, you can see that the growth is so stagnant. But as compared to 2023, there is a huge difference in terms of the growth rate, because of the weather during the 2022 season was totally different as compared to what was happening in 2023. And this you can link it to the Nino index, whether the La Nina year and the El Nino year, or the neutral year. What impact does it have on our fruit production? And also the other problem that we have, I'm finishing now, I'm still left with I think 3 slides. So we have got a problem with sunburn in the pomegranate orchards. So that is one of the key problems that we have. You find that the percentage of fruit that we are losing through sunburn, 44%, 27% of the class 1 fruits that is supposed to go for export, or the extra large fruit that also goes to export. So 53% of fruit that is supposed to go for processing has been affected by sunburn or damaged by sunburn, and some from blemishes. So how do we deal with this problem of sunburn degrees? So there is a solution which I have. When I was visiting a Tatura, a smart farm in Australia, I found them doing what we call agrivoltaics for orchards. So which has got the potential benefits such as lower sunburn losses, less fruit wastage, high peckout rates. You have better resilience, protection from extreme heat, wind, and hail. So more especially in the northern or in the central part of South Africa, wherein we are more prone to hail. So this might also be a solution to the fruit farmers, or even to farmers who are producing vegetables, but also at the end getting energy. So solar will give you energy. You power your pumps for irrigation using the same solar system. So water savings, lower evapotranspiration, more efficient irrigation, on-farm energy savings, offset from the grid, and with cost with solar and weather protection, shielding your orchards from hailstorms. So these are the benefits of this kind of a system, which we need to also conduct trials using these systems in Southern Africa if it's not yet done. And the last part, we look at the water use of apricots. This is the project that is ongoing, which I'm currently working on in Baden in Montagu. This was driven by that drought which happened in Montagu when most of the farmers lost their trees. Now they want to really understand the optimum amount of water which they need for during each and every growth stage. So the same techniques that I'm using, but now we have added the new technology, like the drone systems, the remote sensing techniques, the flow techniques. This is what we are currently using, the Eddy Covariance and also the plant climatic measurements, the photosynthetic measures, all these different technologies. We are using them and also teaching the students on how to use these technologies so that the future generation of researchers will know the technologies and techniques to use in order to continue with this research, because we are not going to live forever. And this is the remote sensing process, which you use different models. Here we are using stable surface algorithm, energy balance algorithm, which I've been working in this part of the project. We are working with an institute in Netherlands called the IHE Delft, which is the United Nations Institute, UNESCO Institute, which did water education. And then we have already determined the crop coefficient for the farmers for the past 2 years on which one, and then how will they are now starting to use this data for irrigation with the combination of with TerraClim, who are conducting some research also in that area, and also with Phytech. So because we're conducting research also in combination with the private industry. And this is some of the results, and you can see the changes from one season to another in terms of the NDVI, your normalized differential vegetation index. How is the health of your crops during a specific time of the year? And then this determines also the certain pockets of the orchard which requires attention. And we give this to the farmers for them to make decision on which side of the orchards to start irrigating intensively. So, and then in terms of conclusion, I will say soil plant and atmosphere continuum describes the integrated system of soil, plants, and atmosphere wherein energy and mass movement continuously from the soil through the plant and into the atmosphere. So the continuous research is crucial on this subject matter, so that we can cover most of the fruit trees that are not covered in terms of research, and so that we can understand better what to do next in terms of saving water in our country. And this research is most of the I will thank funders of this research, institutes which are involved in this research. We have different various institutes: Water Research Commission, National Research Foundation, the Agricultural Research Council, University of the Free State, the IHE Delft. And also, I would like to, the last part, to invite those who are in research related to transpiration and sap flow. Next year, I will be hosting a conference, international conference, and these are the details of the conference. It's a 13th International Workshop on Sap Flow, which is convened by me, Dr. Tharaga, and Prof. Rob Skelton from VETS, and now Dr. Mutianje Ravuruma. This is my student who just recently got his results. He just is of his PhD. And I would like to thank everyone for their attention. Thank you.